Okay, that was so much fun. I'm ready to try another one. No fancy title this time. You know what we're doing. This is just a new problem. This one's actually from your textbook. It's on page 165. If you would like to follow along there, you're welcome to do that, or if you want to use that instead. But I am going to talk you through it. So we're after the second derivative is our goal. But of course, we have to start by finding the first derivative. So I'm going to take the derivative of the left, and I'm going to take the derivative of the right. And when I do that, let's see, I'm going to get, let's stick with weight this time. On the left-hand side, I've got the sum of two functions, so I can do the derivative of them separately. The function 2x cubed, when I take the derivative with respect to x, I'm using my power rule, and I'm getting 2 times 3, or 6x squared. And then when I get to my second function, because that one is in terms of y, my derivative with respect to y is negative 6y to the first, and I have to follow that times derivative with respect to x, dy dx. And continuing on the right-hand side, derivative of a constant is 0. So my goal now, quick recap from last week, is I need to, after I differentiate both sides, collect the terms with dy dx on one side, and I only have one in this case, and I need to solve for dy dx. So that's going to mean that I'm going to do a subtract 6x squared to both sides, and I'm going to get a negative 6y dy dx. And notice I'm writing in a different color just because I always want to keep my eyes on that. This is your algebra problem of solve for y. It just looks different because it's dy dx, but you're really just solving for a variable. And now I need to go ahead and divide by my negative 6y. Get that to cancel out, and I get a lovely dy dx is equal to, and I can go ahead and, let's see, I can cancel the 6's and I can cancel the negatives. Are going to become a positive, and that simplifies pretty nicely for me to x squared over y. I would recommend, if you can, simplify your first derivative before you move on. Because first of all, I need to now differentiate that, and a simpler derivative is easier to take the derivative of. And I'm also going to need to substitute that back in at some point, most likely, as we did in the last problem. So definitely simplify if you can. Okay, I'm ready to move on. So pause if you need to catch up, because I'm going to move this and give myself some more room here. So I'm now ready to take the derivative of that. So if I want to write what I'm doing, I suppose I'm doing the derivative of the left side and the derivative of the right side. Oh, well, let me undo that. I don't want to make things too messy here, so I'm going to actually rewrite that. Dy dx is equal to x squared over y. And I am taking the derivative of the left side with respect to x and the derivative of the right side with respect to x. Okay, you don't have to write that step, but just to kind of show what I'm doing. And then, of course, we have this lovely notation that we use for our second derivative. And that's just the fancy left side. Now, on the right side, I'm actually going to take the derivative and take a look at the function that we're taking the derivative of, and think about what you're going to do, what rule we're going to have to apply from maybe last chapter, maybe this chapter, and see if you can answer that question. Hopefully you are thinking quotient rule right here, because we do have the quotient of two functions. So a little bit more complicated, I suppose, than the last one that I could just rewrite and do the power rule, but no big deal. You guys are fine with the quotient rule. Let's go ahead and do it. So if I'm doing my quotient rule, I'm going to end up with denominator times derivative of the numerator, which I'm going to write as derivative of x squared. I just kind of sometimes like to note that I need to do the derivative. So you can skip this step, but I'm going to go ahead and write it out a little bit more carefully so that we can follow. And then minus numerator times the derivative of the denominator. Quotient rule, so all over denominator squared. Don't forget that part. Okay, a little bit messy, but let's go ahead and actually take our derivative. So what I have in blue, I'm going to go ahead and do now. The derivative of x squared is going to be 2x. Derivative with respect to x, I don't have to follow by anything. Derivative over here of my y is going to be, derivative of y is 1, but because I've got derivative with respect to x, I'm going to have to follow that times dy dx. So I've got y times 2x minus x squared times 1 times dy dx all over y squared, and that is my second derivative. So I can tidy things up a little bit. Let's go ahead and rewrite. And I'm going to have 2xy minus x squared times dy dx. Something should be going off in your mind right now. Recall from last problem that we can't have a dy dx in our final answer. Our second derivative we want to be in terms of x and y exclusively. So we do know something about dy dx, and we're going to have to go up and find something that we know about it so we can substitute in. So hopefully you are looking at yours all on one page, and I'm going to have to do a little bit of scrolling here to find x squared over y was my dy dx. So I'm going down here and I'm now substituting x squared over y in for my dy dx. Denominator, of course, is still y squared. Algebra becomes a little bit more complicated. I'm going to make a recommendation here. You have two options. You can simplify the numerator first, or you can get rid of the complex fraction and get rid of the denominator. I'm going to simplify the numerator first, and I am going to recommend that you do that as well to simplify things. I think it will go better. So if you're looking for my recommendation, let's go ahead and get a common denominator. On the right-hand fraction, I've got a denominator of y, so I need to get a denominator of y over here. So I'm going to multiply times y over y. And I'm now going to be able to, they really need to make bigger iPads. I'm now going to be able to rewrite that numerator as one fraction all over y. So I've really got 2xy squared minus x squared times x squared is x to the fourth all over y. That's me simplifying all of this. And then that's over y squared. And I'm now going to simplify the over y squared, get rid of my complex fraction. So times 1 over y squared and times 1 over y squared. Gets rid of my denominator altogether. And if I can give myself a little bit more room here, I'm going to get something like 2xy squared minus x to the fourth all over y times y squared, y cubed. Let me check with when I solved this earlier, and indeed I am agreeing with my answer. So second derivative, I'm out of room to write what this is equal to. We should put, of course, our second derivative notation. Second derivative is equal to this entire quantity.